All right, we're back. We're still on page 49. We're still graphing tangent. We're still going to try to avoid the number one mistake, which is to do 2 pi divided by b instead of pi divided by b. This is tangent, so the period should be pi, so pi divided by b. So let's see if we can do that. So it'd be ridiculous if I get that wrong now. So pi divided by 5 pi over 4, which is going to give me just 4/5. So there's no pi here, which is totally fine as long as the starting point also doesn't have pi. Anytime you get a starting point with pi and a period that doesn't have pi, that usually just means that something went wrong in writing the problem. It's like nobody really wants that to happen, but occasionally it does. So it's an accident. 1/5, the start. All right, so what I do is I look at this, right? But I put it to the other side, so it's really negative 2 pi over 3. I'm going to multiply by 4, which is negative 8 pi over 3, divide by 5 pi, so that's negative 8 over 15. So negative 8 over 15. So let's change this to 3 over 15, so we can just keep adding all the way across. The middle point is going to be at 9. The high point going to be at 12, and the low point will be at 6, right? So your middle point, you can go up 3, you can go down 3 to get to the high and low points that we graph. The range is all real, so it's not like a maximum and a minimum. That's why we call it a high and a low. The range will definitely be all reals. And now we're ready to kind of like plot it out and see if we can get this. So what are we going to do? I'm going to try to put, I don't know. You know what? I'm just going to take advantage of the fact that I can move it if I need to. So I'm going to say this is 9, 12, 6. So that would be 3. That would be 0. So what do we have above and below? So 9 is really the middle point, right? So 9 is really the middle. So it's above 12, we have 1, 2, 3-ish. And then below 6, we have 1, 2, 3, 4. So there's kind of like nothing we can do about that. So I think that's fine. So what I'm gonna do is put in my x-axis. Nailed it. Oh man, look at that. That's nice work. All right, starting point, negative 8/15. So you try for the middle as much as possible. So negative 8/15. And then we're going each box. Each box is an increment, but we're only going to label every other increment. So that means that I'm going to keep adding 6 over 15. But I'm really going like, so this is negative 5, and then negative 2 over 15, and then whatever, and then 4 over 15, and then 10. Whoops. Ooh, I don't know what I've done. I found some like shortcut to something, but I don't know what. 10 over 15. And then 16 over 15, because I'm adding 6. And then not gonna label that one, too close. All right, so then negative 14, negative 20, negative 26. These numbers are like, as far as problems go, these numbers like feel weird. So like when I check it, what am I doing here? 6. So what happened? 14, 20, 26. This should be 32. Yeah, as far as the numbers go, like I won't be super surprised if I mess this up. Definitely trying not to, but you lose sight of things. All right, now my starting point, I'm going to highlight it. It's not really a normal thing to do. It's just, to keep track of better so you can see it as you're trying to like keep up potentially. I'm going to dot in a sinusoidal-ish axis. I'm going to dot in an axis where the middle points happen. So here, woo, there. So not really a part of the graph. Tangent graphs don't have a sinusoidal axis because they're not sinusoids. But it's incredibly helpful to put that in. So that's why I put it in. Now, what are we dealing with? Negative tangent. So we're going to go With a negative tangent, you just switch the highs and the lows. So it's going to go middle, low, asymptote, high, middle. All right, middle, low, asymptote, high, middle. Middle points are at 9. So we're going to start here at 9. Then we're going to go to the low point. Then we're going to put an asymptote. So I'm going to do that thing again where I try to like steal one and then just duplicate it, because that worked out pretty well for me. I don't know how it worked for you, probably not as well. So I got to copy. I'm going to duplicate this. First I'll move it so that it like works for me. I just did some really fancy lassoing, so hopefully it gets everything. All right, so we got an asymptote here. Now I'm going to duplicate that, and we go high, middle, low, asymptote. Duplicate, high, middle, low, asymptote. Duplicate, okay, low, middle, high, asymptote. And duplicate, low, middle, high, asymptote. Excuse me. Low, middle, high, asymptote, and then low, middle. Okay. I think we have all the asymptotes in place. So now what we just have to do is follow the pattern. So we started out middle, low, asymptote. It's going to go high, middle, low. It's almost like plotting a line, because I mean, those 3 points are in a line. So once you get it going, it should kind of work for you. So then it's going to go low, middle, high, but we're going backwards. Okay, and then I got myself really confused there for a second. I'm pretty sure this is still right. All right, now we just got to like put in our curves. So let's see how well this goes. Last time it went really well. I don't really know. I don't know why. Could just be, maybe I've gotten better. Seems unlikely though. It's like at some point you gotta probably level out a little bit on your skill. There we go. Okay. And these, I'm like stretching my fingers on the stylus as much as possible so that I don't have to put my palm on the iPad. This one, palm soundly on the iPad, so it's like a little less smooth. That's weird. And then what am I doing here? Like, because I didn't have like the whole thing to like get going. So there-ish. I tried. Okay. So domain and asymptotes. Well, asymptotes, let's see. The first one that I'm going to go with this time, I'm going to say I see one at -2/15, which I think the calculator is going to use. And then they look like they're 12/15 apart, which if you divide by 3 is 4/5, which makes sense because that's the period of the function. So negative x equals -2/15 plus, so we're doing 12/15 times n. I like to use the unreduced fractions. Also, if you're watching all these videos in a row, you'll see I repeat things a lot, but that's because I have no way of knowing if you're watching them in a row. And so I say everything as if you're brand new, even though hopefully you're not. You know, could be this. You could watch, if my plan comes to fruition, you could watch my entire math analysis course like straight through, which is looking like it'll be like 70 or 80 hours or more of videos. But man, it's like a really high quality like pre-calculus type thing. So everything you'd need for basically Calc 1, 2, and 3, with some ideas for Calc 4 as well. So this I think is right. I'm gonna check it on the calculator, hopefully. So I'm gonna switch over and see what happens. So first I gotta define the function. Make sure you're in radians when you check this, because otherwise, you know, you're definitely getting it wrong. This, or at least you could get it right, but your calculator will tell you got it wrong, because the calculator doesn't know. All right, let's check a few points. So f of -8/15 should be 9, which is the middle point. That's good. So let's see. The increment is 3 over 15. So f of negative 5 over 15, I'm thinking, is going to be 6. And it is. And let's check the domain. So generally speaking, if you get like 2 of them right and the domain is right, you're probably going to get it right. But that's like a very general thing. I'm going to expand this. So expand is actually menu 3, 3. And it'll expand. I usually just type it. So negative 2 pi over 5. No, negative 2 over, what did I even say? Negative 2 pi over 5? Totally wrong. Negative 2 over 15 plus 4n over 5. We wrote 12n over 15, but that reduces down. So we got it. So the calculator always seems to use the first negative as the like asymptote that it chooses. And I like could not tell you why it does that. Like it seems just as easy to always use the first positive, but whatever. So that's it. All right, so I'm gonna come back in the next video. We're gonna start talking about cotangent, but otherwise, I think this is going really well. Just avoid that one big mistake. Period for tangent is pi divided by b, not 2 pi divided by b. Think of the natural period of the function, think of the unit circle, or just remember it's not the same as sine and cosine. Any of those will be very helpful. So I'm gonna stop this here. See you in the next video where we're just gonna keep going. So hope to see you there.